So at our last XT conference, which seems like only a year ago, but maybe it was longer, who knows, we had Vlad, Revolut's CTO, join us. And he had a fireside chat, and we got to learn a bit more about, how Revolut works and how they've managed to achieve the amazing success that we've all seen. But Vlad could only really scratch the surface, so he talked a little about where they standardize and where they allow teams to innovate. But they were really just hints. And this is why we were so pleased to be able to secure our next speaker. And I actually had quite a few of the invitees today tell me that the reason that they couldn't miss the event today is that they had to find out more about how Revolut works and how Revolut do what they do. And so it's really great to have our next speaker, Donato. He has been instrumental in building Revolut's core banking platform. He's a partner in the firm. He's also their head of technology. And he's a very busy guy. He's also getting married this year and has just moved to Dubai. So pleased that somehow, on top of his work at Revolut, he's also managed to find time to put together a talk for us and come and be with us today. So if we could have a warm welcome for Donato Lucia.
So hello everyone. First, thanks for being here listening to me. I hope I'm gonna be sharing something interesting to you. But to set expectation, not disappoint anyone, I'm not gonna talk about AI today. Well, the plan is actually to talk about some insights from our journey at Revolut and how we somehow managed to deal with our complexity while hyper-growing. But before, I want to slightly introduce myself. I'm Donato, working at Revolut as a head of technology, which essentially means platform. Any platform is effectively what I take care of every day. Solving core problems centrally and scale them as much as we can. I've been doing this for almost 8 years now. Being alive today is an achievement. Yeah, going to the point. I mentioned hypergrowth. Not everybody might know what that means for Revolut, so I want to share an idea. So this is what happened in the last 7 years or so. I have in mind actually second half of 2017. Worth to say that Revolut was actually founded in 2015, summer of 2015, but I chose this moment because I think is when things really accelerated quite dramatically. Coincidentally, is also when I joined. But yeah, we moved from 1 million customers roughly to 55 now. 30 countries, we were mainly in Europe at that point. And I think we just launched business. We were mainly retail, more or less. Now 48, not Europe anymore, and with a bunch of banking licenses, which raised the game. 5 million user transactions, 1.2 billion or so, probably even more today. A different picture in a relatively short amount of time, right? Now, everybody happy, is amazing, investors super happy. But what's behind, right? So with hypergrowth, things get complicated, and they get complicated quite fast, right? So a different perspective from behind is this, right? Back then we had one repo, one service. Well, I mean 5, but reality, I think if I exclude services to run jobs, back office, there was for card payments, which was useful, of course. But effectively, we had one big service, which was serving retail. Anyway, and most importantly, I think we had a very small team, right? A bunch of us, everybody knew each other, everybody knew what line of code whoever was writing at any point in time. But yeah, to support our growth, we start hiring, of course, 15, 20, 50, 100 engineers, and then the trigger, right? So we needed to give autonomy to those engineers, and then we moved to distributed systems. Now, everybody heard about the story from moving from monolith to microservices, so I'm not gonna talk about that. But I want to point out, though, that is a slightly different story, because we didn't really move to microservices. I will say that we moved to services, and we didn't do it even that fast, but we'll see what that means. So yeah, in a simple sentence, we moved from simplicity to a chaotic environment. There was a lot of accidental complexity. A lot of new engineers hired one after the other. They added their own experience, their way of doing things. Things became a bit of a mess. Now, I don't want to teach what accidental complexity is, everybody knows. But I want to give just my perspective to set context. Because typically, we see the speed of delivering as the speed of delivering tasks over the week. But really, that doesn't matter much if you don't deliver any product increment. And accidental complexity is where you start paying this price, because you spend most of your time doing things that are not business related. And that's what we really been always conscious about and try to not get there. Also worth to look from a different perspective, because we are in a financial services, and everybody here understands this very well. But in this space, it's not only about speed, right? But it's also about risk. And in general, when you get to a very complicated system, is effectively like system complexity, and system complexity is effectively classified as a risk, right? Because you get a lot of operational complexity. Now, going to the point, what did we do, right? What did we do to manage complexity while hyper-growing? And I think we managed to go fast, and we are still fast. Well, the idea was rather simple, nothing revolutionary, but probably the application of it. We wanted to introduce a set of standards and invariants that were aiming to reduce the number of choices engineers have to make. Doesn't mean remove autonomy, but reduce the number of choices. And with the idea, to reduce chaos, complexity, and eventually keep high speed. And what we did is we introduced what we call service topology, which is fundamentally a bunch of service types, where each has a specific function, clear function and boundaries, and more importantly, a predefined connection, right? So you can actually connect them only going back downward. So in this architecture, we have front-end API, which is front-end first of all, actually, which is a mobile or web. A front-end API, effectively the front-end for the back-end for the front-end, sorry. A flow is effectively business or logic orchestration. State, which is one of the key guys, is where we have the databases and where we store our models. Gateway access to third parties was actually the only guys that are meant to connect outside. ML model, that was introduced slightly later, of course, for prediction inference APIs. Batch, heavy jobs, event store, one of a kind, is to store events that are mainly coming from state and then streamed back. Now, as you can see, this is effectively leading us to a set of invariants and rules. And you might easily end up in avoiding things like that. So you don't connect things randomly each other. And among dozens of benefits, so not ending up here, at scale, you don't pay other prices such I can give you examples of like going to hybrid setup, right? When you want to move workloads around. Now go figure out to untangle this and move things around. Also, like we enforce like a minimum level of delegation. Keep things simple, but also like avoid chaotic error management and the latency over the systems. And what else? As I mentioned before, we didn't really go to microservices, and we also with service, we didn't go that fast. Indeed, what we said is that each of those service types can actually be stuck together in one deployment, right? And you extract them only when you actually need, right? And this is effectively what happens most of the time. You typically may extract at some point the state because you want to scale it independently or you want any other system to connect to it, but you go slowly when you need it. And by doing that, you also don't allow to connect to any of those deployments in a random way, but always from the top, right? And this will make extraction later easier because you don't have to untangle things as you go. Now, this is exactly what we did in 2018 or so. We said, okay, this is our Bible, this is what we are going to do. And then, let's apply it to our current situation, which at that point, was not necessarily so in order. And what we did is effectively apply all the topology to our existing domains at that point. So we did the exercise of grouping things together and say, cool, those are going to be our front-end systems, those are going to be our state services, gateways, and so on and so forth, right? And then we grouped all of them by domain. Each team start owning those domains, and they had a clear roadmap ahead, right? They knew what they needed to do. Also, like as a consequence, we defined what Revolut architecture was, because at that point we didn't. It was just like make things working. We said, okay, this is going to be our architecture, and we effectively leverage the topology, and is also defining the call direction, right? How systems should connect each other, who should call what. Very, very briefly, like the yellow one are state, and is actually the core part of Revolut. It's a bit extended today, but is effectively like most of the foundation of our core banking system, which, by the way, we built all in-house. Screening, thin crime on the bottom, gateways, downstream, finance, reporting, and so on and so forth. And to be fair, I think this is exactly what Revolut looks like today in the sense of core. Then, of course, a few more things popped up along the way. But this is the thing that you will keep anyway until the last day. Now, effectively from here, everything is just history then. It's a lot of execution, it's a lot of hard work. But any new system, any new domain that was built along the way had a direction. And we didn't accumulate any extra tech debt. Anything that was eventually at that point set as a roadmap is mostly done at this point, so we are quite happy where we are. Now, like all the execution and story in the last 7 years is probably like subject for a talk over a beer. Now, takeaways and tangible benefits that, of course, we wanted at the beginning, but we eventually realized and we noticed along the way ourselves. Now, we gained effectively like a shared vocabulary, or as we may say, like ubiquitous architectural language, both verbal and visual, because all of a sudden everybody knows what a flow service is, what a state service is, and what should be inside that services. It's easy to understand each other. We also know what color you need to use, so effectively also design any SDR, any document, you use that topology. It's easy to understand what you're talking about. You move easily to the problem instead of focusing on how things must be connected to each other, because everybody knows where things must sit, right? Also, like another benefit, this topology, this framework doesn't apply only on a given stack, but is actually generic. So indeed we apply to the whole company, no matter the stack. As I said, we know exactly where things are. For example, you know where the orchestration logic is, where the state is, where the authentication logic is, for example, only on the front-end layer. And this was a great idea, but in reality we figured ourselves along the way that was really good, right? Because applying refactoring was dramatically easier. Not easy, but easier, right? And also enforcing policies, because you can easily enforce some policies on the front-end API because they expose publicly, or gateway that talk outside, but the rest is internal. So it's a lot of things that you can do at scale very quickly. Scalability levers as well. So scalability is not a concern for everybody, but because except all the stateful layers that it's easy to auto-scale horizontally, of course. But reality in this setup, scalability is a concern, mostly for state services. Reality, and give an example. We went through the journey of sharding some time ago. I don't want to exaggerate, but I think it took 2 weeks to implement sharding in our central framework, let's call it this way, and all of a sudden was rolled out to all the systems because we know exactly how state services are constructed, and applying this across the board is quite easy. Actually, extra benefit is that having services specialized on doing something, you also have got engineers very specific to a problem, right? We have teams that all the state of our core banking. They are very deep in scalability. They know how to scale databases. They know how to deal with it. Others might not necessarily have to do that. We kind of understood this already, but security resiliency, reality. For example, having gateways that isolate external failures. Or front end that take care of exposing outside our data. You keep issues local, isolated, and you don't have everybody focusing on the same problem. And you're also ensuring that only some layer are connected outside or exposed outside. You also are able to enforce security policies easier, and it's helping also with audits, by the way. Now, is this all of it? Of course not. But this was as I said, a bit our Bible, and it was the direction that we set back then. I think was also quite pivotal to do it relatively at early stage. It was not that early. I was still unhappy when I joined, and so I see a lot of mess. But still was quite pivotal to do it that early. Then, of course, to do all of it and to keep doing all of it, we have a lot of tooling, right, that support engineers and the company. And we are investing a lot into it. I wanted to mention a key one that are, I think, helpful for us. One is our Alpha framework, which is effectively a way for us to let engineers not keep solving the same problem over and over, but we also help enforcing our framework topology invariance, and effectively also build event-driven systems, CQRS, and so on and so forth. We also have, this was introduced later on, Tower, what we call technology governance. And in there, we have a service map where actually we see also how things are connected to each other. We have cost attribution, of course, scorecards to see how systems are doing with SLO and architectural rules and so on and so forth. It's effectively our infra admin, right? And then lastly, I think also important is our bootstrap libs that are helping engineers to start with the right type from the get-go. And this enforces structure and predictability, effectively, predictability across the company. Everybody knows how things are. Now, reality, each of them deserves probably a deeper talk, but we'll see probably in the future. But that's probably like most of the key aspect of how we deal with that. Getting to closure, to summarize, complexity is inevitable, especially at a scale similar to the way we're operating, where there's a lot of countries, a lot of regulations, a lot of products. It's just like continuous, like every day you wake up and there is a new problem. But accidental complexity doesn't have to exist, right? Of course, you will have at any point in time, but it's not something that you say, no, well, we have to, it's just things are complicated and, you can end up in complicated solution. And as I said, like what we did is effectively like set rules, and this gave us a lot of speed and trust that anything that we're going to build in the future is going to have like a clear place in the architecture, right? And every engineers know what to do. I think that's it from me. Thank you for listening.
Thank you, Donato. So we've got time for a few questions. Pete, do you want to?
Thank you. I thought that was really interesting. You talked a lot about architectural homogeneity, but then you kind of mentioned that you have different technology stacks. You didn't really talk about control of your technology stacks. So to what level do you kind of let that proliferate versus reining that in a bit as well?
Yeah, actually, interesting enough, we started from Scala. And, we quickly, well, I don't want to offend anybody. we quickly figured that was not the right choice for many reasons. But anyway, like and actually along the way, we gave an opportunity also to Kotlin. But then eventually we settled we have Kotlin around, we don't have Scala anymore. We settled on Java and Python, reality. And we have like platform team dedicated on producing tooling for those stacks. So it's centralized as well, right? It's centralized in my department, technology, and we're actually Alpha, which is our key framework, is actually built both for Java and Python, and so we are able to to standardize most of it.
Thanks, that was really interesting. I have two questions if you have the time to answer them. The first one is, what process did you use to decide whether a standard was a good standard or it had to be changed? And the second one was, in your journey to pick these standards or decisions in the framework, is there anything you tried and it didn't work? Like, do you have examples that could be useful for us to hear of?
I mean, I think that happened before I joined, but I think there was an attempt, I'm not sure if we can call a standard, but there was an attempt to use Spring back then, and that's another thing that failed. I don't think we had many iterations, to be honest, except the first one we were leveraging existing frameworks in the industry. I think it was mostly like learning, lesson learned in that first 2 years. And of course, things were adjusted slightly along the way, but I don't think we had many iterations, to be honest. This was like mainly coming from the expertise of like, I think mainly from our CTO. I work a long game for most of the time. I may have contributed a bit into it, but it's mostly like expertise on knowing, that he. I mean, we as an industry, we spend a lot of time to refine ourselves in how to structure code, right? But not enough in how to structure systems. And when everybody went to microservices, it's just been wild, right? And that is more like learning on those experiences and try to see, okay, this is going to be another mess, right? So let's do something about it.
Thanks, Donato. I really want to take you up on your beer offer later. That was a really
Sure.
great, revealing talk. What I wanted to ask, and it might be like a whole other talk, but you talked a lot about the technical design here, but how did you ensure you also designed the social side and the team structures and the other things to allow this technical solution to blossom as well?
Yeah, I mean, well, hiring and structuring teams is yet another topic. We can spend time on it. Reality in Revolut, we invested in engineering a lot, and we have like I say like in Revolut we have an open source community, right? Really like engineers comes first, meaning that what we did a lot is hiring strong engineers and make them a team, and they will be always talking with me, with Vlad, or like all the, the core teams, and have effectively like a networking. We have actually, just to give a perspective, we have the central department, but then we have like a platform team per department, and it is like sort of a network. They report all centrally, right? So to answer straight to your question, I think was a lot of structuring our company around engineering and strong engineering, and have like not make them isolated, but rather have all connected each other. We talk each other. There is no layer of translation. There is no man in the middle. So if there is to talk about tech, is engineering matter.
Hey, thanks for the talk. I was just interested about the alpha library that you have. Am I right in thinking, so is that domain types that you're sharing between different applications?
Alpha is a big guy. I think requires a talk. In essence, like what Alpha does is implementing DDD. Like we have like entity, so commands and queries. That's in the essence what Alpha does. And via doing that, like we enforce some invariants, but it's effectively that, actions, well, we call it them actions, but the commands, change of the state, event, and for like asynchronous processing and query. That's exactly what Alpha does.
So I think we're actually out of time for questions, but if you've got any more, then please do feel free to grab Donato at the break that we've got coming up. So if we could have another round of applause, please, for Donato.